Hello everyone, welcome to our tutorial series on REST APIs presented by Turbo360. Thank you for watching. In this series we're going to create a basic REST API which will follow the standards and conventions of most REST APIs that are in use today. So what is a REST API, you may ask? Well, a REST API is basically a communication layer between multiple machines making requests and responses for data. The actual REST acronym stands for Representational State Transfer, which basically means requests are made revolving around types of data. So a computer, a browser, or a mobile phone might make a request for all profiles in New York City, or it might make a request for all profiles in a certain database that fall under the premium category. This would typically be done through a REST API. The actual API is the communication layer, and it should be consistent across all device types, so all client types essentially. So whether it be a browser or a mobile phone or even a TV or anything like that, like a smart TV, they will all be making the same kind of requests to the server in order to request data types. And that's the idea behind a REST API. It makes it more efficient so that you can create one API which services all types of client requests. Again, browsers, mobile phones, smart TVs, etc. So in this series, we're going to do exactly that. We're going to create a simple REST API using Node.js and Express. We're going to persist our data using the Mongo database. And we are going to use all four, well, there's actually more than four, but there are four primary HTTP verbs. There's more than that, but these are the four that are typically used in REST APIs. Get, post, put, and delete. And these four HTTP verbs essentially represent request types for data, which describe essentially what you want to do with that data. And it's pretty descriptive. So the get means we want to get data. Delete means we want to delete data, obviously. Post means we want to create. Put is update. Finally, we're going to deploy our API to a staging environment on Turbo360 so that we can test it in a live situation. And it's going to be deployed live on the internet so we can make sure everything works both locally and on the actual internet. So this is a beginner tutorial, but we do expect you to understand some basic concepts already. This is not for complete beginners. You should have a basic knowledge of JavaScript and JSON. You don't have to be an expert, but as long as you understand some basic JavaScript and JSON concepts, you should be fine. We do expect you to know rudimentary programming knowledge. So things like variables, loops, arrays, promises, that should all be understood by now. If not, you might want to go back to one of our intro series to get brushed up on that. We will be using MongoDB, and if you have no experience with MongoDB, feel free to check out our tutorial series on that, where we cover Mongo from the bottom up. And we will be using Node Express for our web application. So you should have some basic knowledge of Node Express so that you can get started right away. So that covers the prerequisites. Let's go ahead and get started with the installation of all the tools we need before we actually start programming. So first thing you're going to need is an account on Turbo360 where we're going to deploy our project. So this is free. Head over to turbo360.co and just sign up either here or down here. Use the free account. And this is where we're going to deploy our projects. So go ahead and do that. And then next you're going to need Node.js. So you probably already have it, but if you don't, head over to nodejs.org and download the LTS version. This is typically the more stable version. The S, I think, stands for stable or support, long-term support. So make sure you have that. And then you're going to need the MongoDB. So head over here and make sure you install MongoDB. Actually, you're better off doing it through Homebrew, so you might want to do it through over here. And again, if you have no knowledge of MongoDB whatsoever, then you might want to take a step back and watch our MongoDB tutorial series because that will cover that covers Mongo from the bottom up. So this is our MongoDB tutorial series. And you're going to need an account on MLab for live deployment. So when we deploy our project, it's going to go over here on MLab. This is also free, and it's a very, very strong, robust service for hosting your Mongo servers. So this is a good service to use for your Mongo deployments. And that should cover our installation requirements. Let's go ahead and test that real quick. So open up your terminal. I'm going to head over to my desktop, but it doesn't really matter where you do this. You can do this wherever you prefer to do your development work. And we want to test a few things. We want to test our node installation. So make sure you test your node installation. Test your npm installation. So that's the version of npm I'm running. Test your Mongo installation, like that. So I'm running Mongo 4.0.1. And we do need to install a CLI from Turbo so that we can deploy our project. So the last installation we need to do is npm i-g. We'll do install-g Turbo CLI. And this will install the Turbo CLI onto your machine so that you can deploy your project, your local source code, to your Turbo environment so that the hosting can go live. So go ahead and do that. I already have it, so I'm not going to do that right now. But you can test the installation by running Turbo version, and then you should see a version number. Make sure your version number is at least this or higher so that you have the most up-to-date tools. And that should cover your installation. Most of this you probably already have done, but if you're starting from scratch, then you should run through all the installation to make sure everything worked. Great. Once you've confirmed that, come back to the video and we will get started on the project. The first thing we want to do is create a project on our desktop called REST API. So that's Turbo, new, REST API. So here we're creating a project. This is going to be a Node Express project with Mongo configuration scaffolded for you. And so go ahead and create that. And here it is right here. So let's open this up in our text editor. I'm going to use Sublime. So here's the project we just scaffolded. And if you open up the app.js, this is where the project itself is essentially put together, the app.js of our Express project. Real quickly, we'll go through the project structure. It's pretty simple. We have our views directory for our templates. So this is the home page. We have our request routes. This is where we will be doing most of our work today, or in this series. And we have our public directory for our static assets, CSS, images, and JavaScript. So first thing we want to do is test the actual project on our local machine, on our dev server. So head back to your terminal and cd into the project, like so. Now remember, this is a Node Express application, so before we do anything, we have to install the dependencies as defined in the package.json. So none of this is installed yet, so let's go ahead and install that real quick. And once this is confirmed, we can now run the dev server, so turbo dev server. And this will run a local server on your machine at localhost 3000. So right here is where you can see that confirmation. So we can just copy the localhost 3000 and head over to that in our browser, and we can confirm that it worked. And there we go. So one more thing we want to do is we're going to create the project on our Turbo account. So I'm going to log in since I already have an account. And then I'm going to head over to my projects and click on sites. So we're creating a site, and then we're going to create a project over here, and let's call it REST API demo. And go ahead and create that. And so now we've created a an environment on the Turbo platform where we can host our project. So what we need to do is grab the app ID and copy that, head back to your terminal, and we need to connect our local source code to this project. So Turbo app, like so, and this will accomplish that. And now our project local source code is connected to our staging environment on Turbo. So one more thing we need to do is log in on the terminal. So Turbo login, and you simply log in with the same email and password as before. And now I'm logged in. And last but not least, we want to do a quick deploy. So Turbo deploy, and this will make sure that our project works on our local machine as well as our staging environment, which is live on the internet on a staging server. So that way we can be confident that everything works on both ends. Great. Once the deployment is live, it will give you a staging link where your project is hosted. You can just head over to that link and make sure you see the same thing. And that way we can confirm that our project works both locally and on our staging server. And then we're good to go. So once you've confirmed that, we're ready to get started on our project. In the next video, we're going to begin setting up our REST API and get started. So hopefully you got everything working, and I'll see you in the next video. Hello everyone, welcome back to our REST API tutorial series on Turbo 360. Thanks for watching. In the previous video, we set up our environment and got all the proper tools and libraries installed, and we scaffolded our project. So in this video, we're ready to begin, and we're going to start coding our project. Our project will be a very simple REST API consisting of a database of football players and their respective teams, American football players. I usually pick that because it's very easy to come up with a list of players and teams, so it's very easy to get some data in there. Our API will return data pertaining to those two what's called resources, players and teams, which is basically the types of data we will store in our database. In this video, we're going to set up the actual request structure to return that data, and that's it. So let's get started. So here is where we left off in the previous video. And here's my terminal right at the end of the deployment. I'm going to run the dev server again locally just to make sure everything still works. Okay, so here it is on localhost 3000. Excuse me. Here we go. So everything still works, and the important thing to understand here is how this request is being returned from our Node-Express project. So if you look over here in the app.js, you will see that we have, towards the bottom, we have routes. We have two routes specifically, the index route and the API route. And those routes are set on lines 32 and 33. This index route is the route that's returning our home page. Now you can see the actual code for these routes in the routes directory, index and API. So our index route right here is the route currently being used to return the home page. And we have a couple other sample routes down here showing a few more sample response types. We're creating a REST API. So we want to use the API route right here. And here we have two sample what's called endpoints to handle our REST API. If you head back to the app.js, you'll see that the API route is connected through the /API path. So what that means is in order to access this route, we have to do localhost 3000 /API and then / whatever else the endpoint specifies. Now what I'm going to do here is remove all of this and start from scratch so that you can see how this endpoint is built up from the bottom up. Okay, let's go ahead and get started. We have our router, which handles the request and the responses. So we take our router and we want to connect a GET request. So remember in the previous video I said there are 4 request types. Right now we're going to handle the GET because GETs are the most common and also easiest to test. The first argument, this takes 2 arguments, is the path. So we're going to do test and then comma, and then we're going to add a function argument which takes 2 arguments in itself, request and response. And the response is where we actually return data. In this case we're going to return just some static data. We're going to return some JSON with a confirmation. And now we can test this endpoint by testing this endpoint right here, this path. Now remember, the API route itself is connected through the /API path. So in order to test the entire thing, we do localhost 3000 /API /test, and that's how that's connected. So let's go ahead and take a look at that. So localhost 3000 /API /test, and we should see the JSON that we wrote a few moments ago. This is the test endpoint. This is the test endpoint. So now that we've confirmed that this works, we can use this endpoint to return data as per our REST API. So what we want to do now is to find the data that we want to return. So if you recall a few moments ago, I said our REST API will revolve around 2 types of data, players and teams. And within the context of a REST API, those are called resources. Basically, a data type in the database is a resource. So we have a player and a team. Those are the 2 resources we will focus on for the duration of this tutorial in our REST API. So what I'm going to do right here is create an array of players and another array of teams. And within the players array, I'm going to add a couple players, sample players from American football teams. So let's go with, let's see, first name. Okay, so here I've created my first player, and really what I'm doing here is I'm creating the schema for our player object. So a player in our quote-unquote database will be first name, last name, position, age, and team. So now that we have that set up, let's add maybe 2 more players, just so we have some more data. Okay, so we now have 3 players in our database, or well, it's not really a database, it's just static JSON right now. Eventually this will be moved over into our actual database, but right now we're just using some quick static data. So let's go ahead and also create a couple teams. So like before, what we're really doing here is we're creating the schema. We're defining the schema for the teams in our database. So I'm going to add 2 more teams. Let's see here. Patriots. The RAFC. Okay, so now that we have some fake data to work with, what we want to do is we want this endpoint right here to return this data based on the nature of the request. So what we can do here is create a team or a player endpoint, and this endpoint will now return all the players in our database. So we can just do players like that. So now if I do localhost 3000 API/player, I should see our 3 football players in our database. And then I can create another endpoint for team, which will do the same thing. So here, this endpoint right here will just return the array of teams. Whoops, team is not defined because I forgot the plural here on line 28. My apologies. So let's try that again. And here we go. Great. So now we've confirmed that the endpoints work properly. So what we want to do now is make this a little bit more general. So remember earlier I said the teams and the players are called resources. So what we want to do is combine these 2 endpoints into one endpoint and have this this part of the path defined as a variable called a resource. So what we want to do is get rid of all these actually. And we want to do router.get and then /:resource. And this will specify this part of the URL as a variable. And the callback should be almost the same. So we want to extract this variable from the URL. So we want to do resource equals rec params resource. And by doing this right here on line 19, rec params resource, we are grabbing whatever the value of this string is. And if resource equals team, we send back the array of teams. Of course, if the resource is player, then we send back the array of players. So now we can combine these 2 separate endpoints into one that's more general using a resource variable, what's called a request parameter. And then we can use that to specify which data to return. So now if I test it over here, it should really just be the same. Now, last thing we want to do is cover for a scenario where the resource is undefined. So we have team, we have player, maybe the person mistyped. Hello, and welcome back to our REST API tutorial series presented by Turbo360. In the previous video, we set up our API route so that it can return some static data which was hard-coded into the route file itself. So obviously that is not going to be the long-term structure of this project. In this video, we're actually going to take that data and put it into our database, our Mongo database, so that we can return data from our actual persistence layer, which will make the project more realistic, and so that we can eventually set up all the requests to interface with our Mongo database. So make sure you have your Mongo set up, ready to go, and the installation properly finished, so that you can follow along with this tutorial series. And that's it. So let's get started. So here's where we left off in the previous video, and I'm going to run the dev server again just to make sure everything still works. Let's head over to localhost 3000, and here is the home page. And let's test the endpoints that we wrote at the end of the last video. So here we have our 3 players in our seed data. We have our teams, and we have the error scenario, and we are set to go. So now what we want to do is throw all this into our Mongo database. So again, make sure you have Mongo properly installed. You can check it right here. I have version 4.0.1, and what I'm going to do is head over to the root directory of the project, and I'm going to create a new directory called seed. and this is where we will store our seed data. So cd into that directory, and let's create two files, teams and players. These are going to be JSON files. So I made a mistake right there. Let's get rid of the mistake. Which will store our original seed data. So we have our players and our teams. So what we want to do is grab the list of players. We have our three JSON objects, and copy that and throw it over into our players JSON file. Now this is just going to be just a set of JSON objects. So we actually don't want these commas. We just want pure JSON objects, and we want to throw these keys into double quotation marks like that. So we're formatting our JSON a little bit more in compliance with strict JSON rules. So I should have done that to begin with, but it's a minor adjustment. Just make sure you throw all the keys in double quotations like so. So now we have our players JSON file set to go, which has our same three football players from the previous video. So now we want to do the same thing with the teams JSON. So we head over to our teams array in the API.js file, and we just do the same thing, pretty simple, and just remove the commas because this is not an array. It's just a set of JSON objects, and throw the keys into quotation marks. Now what we want to do is use these files to insert data into our Mongo database. So this is going to be now inserted into our Mongo database. So first thing we need to do is open a new tab in our terminal by doing Command T, and in here we're going to run our Mongo database by using MongoD. So we need to have a local instance of Mongo running in order to do this. So make sure you do that, and you see this line at the end, waiting for connections on port 27017. This means your Mongo database is locally running successfully. So now what you want to do next is here we want to use a tool called Mongo import to take this data and throw it into our local Mongo server. So let's go ahead and do that. So we want Mongo import. It takes a few arguments, --db, which is going to be the name of our database. So let's call it football DB. And then collection, and this is going to be the name of the Mongo collections. So it's going to be players, and then file, and that's going to be literally the JSON file that we just created. So players.json, like that. And this should create the three records for each individual player in this file. And in addition, it should create the actual database itself called footballdb, because we didn't actually create that database beforehand. So now that database should be created for us as well. So we should do the same thing, except instead of players, this time it's going to be teams. And this should carry out the same process for the teams JSON. So there we go. So now we imported our 3 documents for players and 3 documents for teams. So what we can do real quick is we can locally connect. So Mongo, and I believe it's called footballdb. So Mongo footballdb. So now I'm connecting to this database, and I can show collections, and we have players and teams. And we can do db players, find, and here we have our 3 players, J.J. Watt, Tom Brady, Eli Manning, and then we can do teams, Patriots, Giants, Texans. So everything worked. So what that means is, and let's disconnect real quick, Control-C. So what that means is our Mongo database is now prepared with the same JSON objects that we used over here to see the data so that we can now interface directly with the Mongo database for our REST API. So again, just if you recall, these are called resources. So we now have our resources set up in our database. Let's go ahead and get our database connection going. So head over to your app.js, and here is where we connect to our Mongo database in our web project. If you look at line 4, you'll see that this is where our app is initialized. But if you look down here on line 24, you'll see another app initialization option, which takes a config object. And inside the config object is where we establish the database connection. So we will be using this instead. So let's go ahead and get rid of line 4 because we're not going to use that. And instead, let's uncomment this, line 21, and we can remove all this. And so now we are going to initialize our project using this config object. And inside the config object is where we establish our database connection, which we're doing here on line 7. Specifically, the URL is where we tell our project where the database is located. So we're going to comment that out, and instead we're going to add a new URL pointing to our local Mongo connection. So MongoDB localhost / and then the name of the database, which in our case is footballdb, right here. So we want to do localhost and then footballdb. And this will connect our project to our local Mongo instance so that it will have access to this data, this seed data that we set up a moment ago. So we can go ahead and confirm that by also adding an onSuccess callback. So let's do comma right here, onSuccess, and then console log football db connected. And this onSuccess callback will be invoked once the database connection is successfully established. And this will be, the error will be invoked if something goes wrong, naturally. So let's go ahead and test that. So our database is still running in this tab, and then over here we can do turbo dev server, and this time we should see a callback. Whoops. Head back to our root project, the root level of the project. So make sure you're in the root level, and we want to do turbo dev server and football DB connected. So this worked. Everything is successfully set up with regard to our local database connection. So in our database, our local database, our local MongoDB also has some seed data that we set up a few moments ago. So now we're ready to go with the actual data from our database. So in the next video, what we're going to do is create our database schemas. I'm gonna go through that pretty quickly because that's well covered in the Mongo series, and then we're going to use that schema to make API requests inside of our API route. So all of this will be removed, and we will actually make the requests from the database itself. So hopefully you got all that working. Stay tuned for that, and I'll see you in the next video. Hello, welcome back to our REST API tutorial series on Turbo 360. In the previous video, we set up our Mongo database connection and we added some seed data to our DB so that we have some data to work with. In this video, we're going to now organize our API endpoint around the REST principles of fetching, creating, updating, and deleting data. We're going to begin with the fetching, but before we do that, we have to set up our database models so that our web application can properly interface with our DB. So let's go ahead and get started. Here we are at the end of the last video, and I'm going to head over to my terminal and run the MongoDB. So MongoD. And again, make sure you see this line down here, which confirms that it's working. Head over to your web server and run the local dev server. and let's confirm that everything still works. So we have player, team, and test. Great. Okay, everything is still in working order, so let's go ahead and head over to our web server, our project root directory, and let's create a new directory for models where we will create the individual schemas for player and team. So let's cd into that, and let's create each one right now. And as I said in the previous video, I'm going to go through this kind of quickly because this should be reviewed by now. But if you don't know what I'm doing here, take a look at the MongoDB tutorial on Turbo, which is right here, and where we cover this concept in more granular detail. So I'm going to create the schema for player. And luckily, we've already essentially done that using the seed data. If you take a look at the seed data for players, you'll see we already have the schema: first name, last name, position, age, and team. So let's go ahead and set that up inside here. First name, last name, position, age, and team. Of course, these are strings. We'll set the default to empty string. Except for the age, which is a number, and we'll set the default on that to 0. So now we have our player schema set up. Let's go ahead and just copy and paste that over into our team schema. Obviously replace these references. And the team's schema is name, city, and conference. So it's even simpler. So name, city, and conference. Okay, and this will cover our two schemas that we need. So if we go back to our API route right here, we no longer need to reference this. So what we're going to do is we're going to import both of those models. And right now I'm going to set up an individual get for each one of those. So team, which takes a rec and a res. And in here is where we will query for all the teams in our database, current Mongo database. So that's going to be a find request. Pass in null for now as the query parameters. And this returns a promise. And in this case, the error is thrown by the promise. So we can throw an error message right here and just pass the actual error message back to the client side. And then here is where we have our success confirmation. Callback, I should say, is better phrasing for that. And then we can just return the data from the MongoDB query. So let's go ahead and test that out. So over here, we still have our MongoDB locally running. We can run the Turbo Dev server. Looks good. Let's head over to localhost 3000 and test the team endpoint. And here we go. Now notice that this is a little bit different. This is actually coming from the MongoDB because now we have an ID attribute which was assigned by the Mongo database. So this is certainly coming from the MongoDB. So this query was successful. So we can certainly just duplicate that for the player request as well. Just copy and paste it. And then we can have player here instead of team. And it should be as simple as that. So now we can test the player endpoint. And here we are. Great. So this is now successfully returning data from our actual Mongo database, which is definitely more realistic. So this endpoint is now no longer needed. And this initial set of seed data we can get rid of because we're now using the actual data from the database. So that's a step in the right direction. Now, if you go back down to where we initially had the endpoint here, you may have noticed this is more concise and more extensible. It's more flexible, really, than the two test endpoints we set up here. In other words, we kind of took a step back. So what we want to do is we want to move these DB queries into separate files so that we can go back to this more modular or more concise endpoint for all resources rather than writing separate get endpoints for every single resource. Because if you think about it, your project is going to have probably more than just 2 resources. It might have as many as 10. So if you have 10 separate get endpoints for all the resources, that can get a little bit cumbersome. So what we're going to do is we're going to head back to our root directory, and we're going to create another directory called controllers and cd into that. And this folder will basically be responsible for managing the queries for each data type, each resource I should say. So we're going to start with an index file, and then we're going to create a separate controller for each resource. So we're going to have a controller for player and a controller for team. So team controller and player controller. And then head back to the root directory. Now if you open up the controllers directory, you'll see that we have all the files. So first thing we want to do is inside the index, we're going to use this one file to export all the controllers. So we need to import them first, obviously. Actually, we're going to use const here. Okay, so here we simply have an export command, which will export each controller by this key, these keys. So this is a simple way to export multiple files rather than doing it one at a time. So let's head over to our team controller first, and inside here we need to import the team from the models directory, and then so here, this controller, like I said earlier, will be responsible for handling all the queries as it pertains to the data type, the resource, in this case team. So what we want to do is set up a get function like this, and it will take a params argument, which we won't worry about for now, but we'll just leave it there when we do need it. And then we can do team find, we pass in the params, okay, so here is a promise sequence where here we have the success block and here we have the error block. Now what we want to do is we want to return this function itself also as a promise. So what we want to do right here is we want to return a promise like so. A promise takes an argument like this, a function argument, which has a resolve and a reject arguments inside. And we take the database query and we insert it inside the promise, like so. And then here in the success block, we simply resolve the promise. That means it was successful, and we basically complete the sequence. And then in here, we reject the promise and we pass in the error so that the calling, whichever file is calling this function right here, can receive the error and then send back the proper error message. So here we're basically wrapping the get request, the find request, inside this get function of this controller. So we can apply the same principle to the player controller. Just copy and paste, and then player, and player, like that. Very simple. So now we have our two controllers with our corresponding get requests. What we want to do is we want to use the controllers in the API file rather than the actual models themselves. So what we want to do is import the controllers. And we can remove this now. Actually, I'll leave these behind for now. And then let's set up another router get. And this time, let's go back to the earlier type where we had a generic resource parameter in the request. And the resource parameter here specifies essentially which controller we want to use. So we grab the resource as a variable. And then we grab the corresponding controller. Should be like that. So if you recall, one of the first things we did was we exported each controller in the index file using the resource name as the keys. So we're leveraging that right here. So this could be /API/team, and then we grab the corresponding controller using the resource name from the controller's index. And then the controller itself has so far only a get function. So first thing we want to do is check if the controller exists. It might not even exist. And then here we send back the error message that corresponds to that. So the confirmation here is fail message and then invalid resource, just like last time, because the controller, the corresponding controller, doesn't exist from the resource that's being specified. If it does exist, we simply call the get command, which is this one right here. And then here we return the promise If you recall, the controller itself returns a promise. Henceforth, we can use that promise here and apply the same logic. So then here, it is a success callback, and we can just return the data. And here, the confirmation, of course, is fail, and then we can pass the error message back. So what's going on here on line 29 is that this error was being thrown as per this reject command right here. So now what we have is an endpoint that handles GET requests for any resource specified in the actual API query, and it also handles the corresponding error scenario if the right here, if the resource specified doesn't exist. So hopefully that makes sense. Let's give it a run. Let's make sure everything works. So my database is still running. I'm going to run the local dev server. And here I have an import error, so let's find that. Team controller, line 1. So I forgot to finish it like that. So models slash team, which means I probably made the same mistake here, slash player. And now we are set to go. So I'm going to restart the web server. Now we have that confirmation message. And again, just in case you missed that, in each controller file, I forgot to actually specify the model file itself. So it should say models.slash/player over here and models/team. So my apologies for that. So now we can run the same API queries as we did earlier. So we can test this one, and we still get the success. The team endpoint still works. And then the test error endpoint, invalid resource. So now, inside of our API file, our API route file, we can now get rid of these original endpoints as well as these model imports, because our controllers are now handling the actual queries. And if you take a look closely, you'll see that the actual references to team and player are not even showing up here at all. So this is a much more robust and extensible way of handling API requests, because everything is in the controllers. And we still cover the situation where the controller, the resource doesn't exist because it may be a typo or a misunderstanding in the API request of some sort. So now this GET request can handle pretty much all the scenarios necessary, and the controllers are doing the bulk of the logic. So this is a more modular way of organizing your API setup, and so far so good. Hopefully you got all that working. I went a little bit fast in this video, but a lot of it was review, so hopefully you were able to keep up. In the next video, we're going to create more granular requests. So right now you may have noticed that we have requests for player and team, which always returns all the players and teams, regardless of what we want. So in the next video, we're going to set up request filters, as well as being able to request individual entities, individual teams and players based on the unique ID. So stay tuned for that. Thanks for watching, and I'll see you in the next video. Hello, welcome back to our REST API tutorial series brought to you by Turbo360. Thanks for watching. In the previous video, we set up a series of controllers to handle our queries to our Mongo database for resources, and then we reconfigured our main endpoint, our GET endpoint, to return that data using those controllers for teams and players. So in this video, we're going to continue that process by setting up more queries for different kinds of queries for specific entities, as well as setting up the infrastructure for setting post requests and update requests and deletes and things of that sort. So that's it. Let's go ahead and get started. So here is where we left off at the end of the last video. I'm still running the Mongo server, and I'm going to run the local dev server just to make sure everything still works. So here's the API endpoint for getting all the teams. Here's a one for all the players, and here's a test failure endpoint, and everything still works. That's good. I'm going to turn off the server. And here is the only endpoint that's in use right now. So at this juncture, it's good to explain the idea behind these endpoints and how they should conform to a REST API architecture. So you may have recalled in the first video we discussed the 4 HTTP verbs, which are get, post, put, and delete. So get, post, put, and delete. And here we are using a get to literally get all the entries, records of a specific resource. And that's what the get is used for. The get is very self-explanatory. It literally gets data. So this is one core tenet of a REST API, is using the verbs to do what they describe. Get, post is for create, put is for update, delete is exactly what it sounds like. So that's one key principle behind the REST API. So we're going to continue using the get to create an endpoint for getting an individual resource, a specific record. So here, where we have all these players, maybe I want to do a request only for this individual player, JJ Watt, using his ID. So we can set up another endpoint just for that. So if we scroll down here, we want to set up another endpoint with a resource parameter, but then in addition we want to add an ID parameter, and this is to specify literally which resource we want. And then we add the rec-res callback. Now here we have two parameters, resource and ID. And the REST portion of this endpoint is the actual structure of the path. This is important. So here we're specifying the resource as usual, and then we are appending that with the ID, and that is in compliance with the overall REST API design structure. So going back to the actual URL here, you can see that we specify the resource, and then if we continue appending to the URL itself, the next string should represent the ID of the individual resource that we are requesting. And this is the REST concept behind the URL pattern that we're putting together. And that's how we normally create a request for a specific resource according to REST design principles. So here, we now do the same thing as we did earlier. We fetch the controller, using the resource identifier. And if the controller doesn't exist, that means the resource requested is invalid. So we return the error. And that should handle that. Now if we grab the controller, we can now make a request for a specific resource using the ID. But the problem right now is that if you actually look at each controller, we don't have a function, a method in either one to handle that. So if we head over to the player controller right now, let's go ahead and set that up. We want to do get by ID. Whoops, excuse me. Where the function itself takes an ID string argument. And then this should return a new promise, just like the one before, which takes a resolve and reject arguments. And the Mongo/Mongoose API function for this is find by ID, like that, where we pass in the ID. And this also returns a promise. Where we can simply resolve and reject based on the success or the failure callback, like so. Now what we want to do next is create a corresponding function method in the other controller, team controller. So we do a comma here, and then paste that in over there, and then replace this with team. And now we have individual document requests in each controller. So we can use these functions over here inside the API route. And then we can pass in the ID, and then we complete the promise sequence. So here we return the failure confirmation. And here we return the success confirmation. And this data object in the callback is the individually requested resource. So the player or the specific team based on these database queries right here. So we can now test that. If we go back here, make sure our Mongo server is still running, head over to our project root and run the dev server. Open up your browser, and here we have the player endpoint, which will return all the players currently in the database. Now, if I want only this one player instead, if I'm making an individual request, I can now pass in this over here, like so, and it will return that individual player. And I can test the other ones as well, like so. The important thing to understand here is that the REST architectural concept here, the REST API concept here, is the URL structure. We have the resource being requested, and then if we want to request a specific resource, we pass in the ID, the unique identifier, next after the slash, and that's the URL pattern as specified by REST architecture for properly requesting an individual resource. If we do not pass in the specific ID, we get all of the resources fitting in this specified resource here. Don't forget we have another resource for team, so we can test these as well. So we have this team. We can grab the ID and test that, and then try the next one. Now we should test the situation where the team doesn't exist. So if I pass in some random string, here we're getting the confirmation, and here's the message being passed back to us from the controller right here. This is the specific reject call that's happening right here. Now this message is a little bit opaque. It's a little hard to understand if you're not a programmer. Basically what this is saying is that we couldn't find the record that you're looking for in our database lookup. So rather than passing back the actual error from here, from the mongoose call, we can just create our new error, and team not found, like that, and we can grab the ID and pass that through, like so. And this way, when we make the same request, now we're getting a more human readable message. It makes it much easier to understand what went wrong, and we can adjust accordingly. So now don't forget, we want to do the same thing in the player controller. Except it should be player not found, like so. And these error messages are basically messages you're preparing kind of for yourself, such that when you work over on the front end side of your project, if you make a mistake like this, you're sending yourself sort of a message kind of in the future saying, you made a mistake, and most likely this is where that mistake is. So little things like this have saved me a lot of time in my own development projects when I make silly mistakes along the way, especially on the front end. So this is now working, so we are good to go there. So now I want to finish up with one last thing. Here we have the general resource requests for all the players, and here's the one for all the teams. If we only want certain players or certain teams, like for example in this team request, let's say we only want teams in the AFC. Well, that would happen through the GET request, obviously, as well. But it would also literally happen through this URL structure, or at least it should. So what you want to do is pass in a query filter like this, conference equals AFC, and you want to have it return only the AFC team. So in other words, this team right here, the New York Giants, should not be returned in this request. So the way you do that is by going back to the API route right here, and it's important to recognize that this query string right here, everything after the question mark, is inside the rec.query object. So we can do const filters equals rec.query. And then we can pass in these filters in the get request of the controller, just like that. Because if you recall, inside the controller, it takes those params or filters and passes those into the Mongo query right there. And Mongo should honor those filters. So if we now run this request, we now have only the AFC teams. And if we pass in NFC, we get only the NFC teams. And if we pass in gibberish, we get an empty array because no team satisfies this constraint. NFC. Great, and that's it. So for now, this will serve as the get endpoints for our API. And this is good enough for now, at least for this project. And so our API has essentially begun in terms of getting data. So now we need to get ready for the other HTTP verbs, so post, put, and delete. And each one of these verbs carries different responsibilities. So post is to create data, put is to update, and delete is to delete. So in the next video, we're going to set up a post endpoint for creating data according to whatever resource we want to create. And we will test that and make sure we can add new entries into our database using the REST API post requests. So hopefully that makes sense and that you got all this working, and I will see you in the next video. Hello, welcome back to our REST API tutorial series on Turbo 360. Thanks for watching. In the previous video, we finished up our GET request endpoints by setting up a route and endpoint for an individual record GET request, where you can query for an individual team or player based on the unique ID. So that will complete our GET request structure, and in this video we're going to move on to the POST requests, which in a REST API architecture is reserved for creating new records. So in this video we're going to create a POST endpoint, which we will then use to create a new team and a new player. So that's it, let's get started. So here we are at the end of the last video. I am going to run the Mongo local server. And as always, make sure you see this last line right here, waiting for connections on port 27017. I'm going to head over to the project root directory and run the turbo dev server. Okay, we're good to go there. Let's head over to localhost 3000 and test the profile endpoint, the player endpoint. So that looks good. The team endpoint, and we'll query for one individual team just to make sure that still works. Great, everything is good to go. So let's turn off the dev server, head over to the API route in the routes directory, and let's create our first post handler to create new records. So this is going to be router.post. And the request parameter will be resource, same as usual. And the callback takes a request in a res object, response object. So we're going to grab the resource from the request params. And as always, we're going to check if the corresponding controller exists. So we check the controller's object for the controller specified by the resource. And if the controller does not exist, that means it's an invalid resource. So we return an error message. Okay, and that takes care of that. So now we need to take the controller and call the post function, but inside the controllers right now, we don't have any post functions. So in the controller, in the player controller, let's create a post function, which takes a params object, and this will be sent from the request, and it will consist of the attributes of the new record. So first, the email, the password, the name, things of that sort. And this will return a promise and inside the promise we will actually create the new record. So in this case it's going to be a player, and the Mongoose function for that is called create, and where we just pass in the params, and then that returns a promise where we just complete the promise sequence, same as the other examples. So here it takes a data callback, and then we resolve the promise here, and here's the error handling. So since this is basically the same in the other controller, I'm going to copy and paste that. Don't forget this comma right there, and then don't forget to replace that with team, like so. And now both of our controllers have the required post functions to create entities. So we can go back to our API route and call that post function and insert the params. These params come inside the request.body. So it's important to understand that this is where the params are sent from the request. And then this returns a promise. Here's the success and here's the failure block. And same as always, we can just return the failure message here. And the success confirmation here. And in this case, the data callback argument is the new entity that was created, so the new team or the new profile, etc. So now we have a simple post handler for creating a new record, a new entry in our database, and this conforms to the REST API architecture. Post calls should be specifically for creating new entries, new records, new entities. I think entities is a better word here. So this is in compliance with the REST API architecture. So now the question is, how do we test this? Because the browsers send GET requests, which is why we usually begin with GETs, because they're easiest to test. But the browser naturally doesn't send a POST request. So there's a couple ways we can do this. We're going to use the terminal using the curl. We can send request, HTTP requests, using the curl function in our terminal. So let's go ahead and set that up. So in your terminal, open a new tab and type in the following curl, and then we're going to send an HTTP request with curl to our post handler to create a new team. And if you look at the team schema, that requires a name, a city, and a conference. So let's go ahead and do that right now. So curl, first thing we need to do is set what's called the headers, and that's going to be content type. So what's going on here is that we're specifying inside this request we're going to add JSON parameters, a JSON type to the request, which will represent the attributes, the body, of the request of the, in this case, the attributes of the new team. And then here we're saying what kind of request is it. So this is a post request. So that should be pretty self-explanatory. And then this flag actually is the JSON parameters that we're sending in, the actual body attributes. So name, city, and conference. So this has to be in JSON form. So name, Bears, city, Chicago, conference, NFC. And you want to be extra careful here to make sure that your JSON is properly formatted. Otherwise, it will get rejected by the server. And then last but not least, we have to actually insert the URL. So that's localhost 3000. And don't forget, we're sending in API requests, so /API. And we're creating a new team. Just want to get this all in one line. /team. So we are sending in a localhost 3000 API /team request as a post request with the following JSON body, and that will then send the request to this API handler, assuming we made no mistakes, and it will return this callback, this payload, excuse me, whether it's successful or whether something went wrong. Let's go ahead and test that out. Failed to connect. I think it's because I forgot to run the server. So run your local web server. Okay, the web server is running. We can just redo all that by pressing the up arrow, and then we try it again. Invalid resource. So localhost API team, and let's see here. So here, I forgot on line 67, it says rec.params. It should have said rec.params.resource because I forgot to parse out the resource variable. So that's why. So how did I quickly decipher that? Is because this is the error we're getting. That means something above this line is where something went wrong. So I forgot to parse out the resource key. And this is why we add error messages into our backend, so that when we make mistakes like this, which is very typical, very common, you can quickly decipher where it broke down, and then diagnose the problem, and then hopefully make the correction. So that's what I forgot. So make sure you catch that on your code as well. And then we just try it again. I press the up arrow, and then rerun the curl command. And here we have the success callback with the name of the new team, the city, the conference, and then the unique Mongo identifier that corresponds with it. So now if I go to my browser and I run a query for all the teams, we now have the Bears included right here. And so that was just added via the curl command we had sent earlier. So now, since this endpoint covers all the resource types, we can do the same thing for player. So player has first name, last name, position, age, and team. So let's go ahead and do that. So here, I'm pressing the up arrow, and I have the previous curl command for teams. Let's make it player instead, which means we now have to change the JSON that corresponds with it. So let's go ahead and go back here to update our JSON values. So first name, let's see, who do we not have? Last name, age, Now notice here on this one, I'm not putting it in quotations because it's a number rather than a string. Or GB Packers. Okay, so now we're sending a curl request as a post to the player endpoint with an updated JSON object for the new player, in this case Aaron Rodgers. We have first name, last name, age, and team, which conforms to the schema here. I forgot position, so let's take care of that real quick. And let's test this endpoint request right here. So let's make sure I didn't make any mistakes. Okay, let's test it out. And here we have a success callback. And here is the new entry that was created. Aaron Rodgers, quarterback, 35, Green Bay Packers. And here is the Mongo ID. So we can just grab the Mongo identifier, Mongo ID, and just make that individual request right away. And there is the new player we just added into our database by virtue of this post route that we created earlier. So that's it. This is successful. We are now creating new entries by virtue of this post endpoint. An important thing to point out is that this is usable for all the resource types. So we did the player and the team. So this can be extended to as many resources you have in your project. So this is a good way to organize your endpoints. So that's it. Hopefully you got everything working. In the next installment, we are going to create a put handler to update records. So if something changes, let's say one of the players gets traded or something along those lines, we need an endpoint to handle that for updating records. So that will be a put handler, and that will be in the next video. So thanks for watching. Hello, welcome back to our REST API tutorial series on Turbo 360. In the previous video, we set up the post endpoint for creating new entries in our database, new players and new teams. And then we tested that using the curl function on the terminal. So in this video, we're going to continue that process by setting up a put endpoint so that we can update current records in the database. So for example, if a player changes teams or position, things like that, we want to have an endpoint that can update that resource and make sure that it's compliant with REST API architecture, which means it should be a put for updating entries. So let's go ahead and get started. So here we are at the end of the last video, and we have our post handler here, and I'm going to run the Mongo server locally, as well as the web dev server. And then test one of the endpoints. So here we have our players returned from the API, and this is the most recent one. Let's say we have to update one of these records. Let's say the age is off. Maybe he's a year older now. We want to have an endpoint to set that up, and that's normally done through put in a REST API. So let's head back to our code and set up a put handler. So router.put. And this will take a resource parameter as usual, but it will also take an ID parameter so that we can identify which resource particularly is being updated. And then the usual callback here. Now, since we've done this a few times already, I'm going to do the controller check just through copy and paste, because by now this should be repetitive. So here, I'm grabbing the resource from the request, checking if the controller exists, and if it doesn't, then we return a corresponding error message, and that's same as usual. So now the controller should have a put function associated with it, but before we get to that, we have to grab the ID. Actually, we can just pass it in as is, so rec params ID. But then we also need to pass in the actual updates, the fields that are being updated, and that's going to be in the body. So just like a post request, the put request sends the payload, the request payload in the body, the request params. And then this should return either a success or failure callback. And then in the case of failure, we'll just return the usual error message. And in the case of success, we will return the updated entity. So this data argument in the callback is the updated version of the resource being changed. Now you probably figured out by now that this put function doesn't exist within our controller, so this code will crash when it runs. So we can't test it yet. So let's open up our player controller and create our put handler. Don't forget this comma right here, it's very easy to overlook. And then the put handler takes an ID and a params object. So this will tell us which resource in particular is being updated by resource identifier, the Mongo ID. And then the params are the actual fields being updated. As usual, this will return a promise, which takes a resolve and reject argument. And we are inside the player controller right now, so let's do the corresponding mongoose function for that, which is find by ID and update, where we pass in the ID and the params. And then we actually have to pass in one more argument here, which is new equals true. So this is a weird little nuance of mongoose where unless we pass in this, specify this object here, this boolean, it will return the previous record before the update, which will make it look like it didn't work. So it's very confusing, but just remember that. And then here we run the callbacks for success and failure. And these are the same as in the other examples. So there's really not much new here other than the actual Mongoose API call here. That's performing the actual change. So that's key to remember. Now, the other controller is not updated yet, so let's go ahead and take care of that. That's the team controller. So let's put a comma here and paste that in, and don't forget to change this to team. Otherwise it will crash. Okay, so now we have the corresponding put handlers in both controllers ready to go. So if we go back to our API route, this is now connected, and we can just test the query by passing in a request with the ID and the request.body. So we're going to use curl again for this example because the browser does not automatically do put requests. There's no easy way to do that through a browser right away. Well, there are, but we're not going to use that. We're just going to use curl. So let's head back to our terminal. Make sure the web server is running, and let's open up a new tab, and let's create a curl request to our put handler. So what we want to do is select one of these records. Let's say it's this one right here, Aaron Rodgers, and we're going to change his team. Let's say he gets traded. So let's grab the ID, and then we want to do curl. First thing we need to do is add a header, and that is going to be content type application JSON. And here we're specifying that the body that we're going to attach to this request is of JSON format. So let's specify the request type. Of course, this is a put. And then we need to actually insert the JSON itself. So that's going to be like so. Now here we just need to add the fields that are being updated. So let's say New York Jets. And then last but not least, we have to actually send the URL of the request. Include the URL of the request, which is api.player, And then don't forget to paste in the ID, the specific ID of the player being updated. And this should send a pull request to the endpoint that we just wrote. Specifically updating this player, Aaron Rodgers. It should update his team to New York Jets. So right now it is Green Bay Packers. And the rest is just request formatting. Let's go ahead and try it. And there we go. And notice here it says team NYJ. So if you look at Aaron Rodgers right here, the team is Green Bay Packers. But if I reload the page, now it says NYJ. And that's it. It's a very simple put request, updating one specific entry in the database in the backend as per the design parameters of a REST API. So the important takeaway here is that the put is meant for updating resources according to REST API design architecture. So that's why we're doing this as a put. Now we can really just set this up any way we want to, right? We can make this a get as well, but that would be poor design structure. So the main point here to take away is that we are conforming to the REST API design patterns, so that this API is what's called, it's easier to what's called consume. It's to interpret and use by other developers. So the last endpoint we want to work on, which we will do in the next video, is the delete. If we want to remove an entry, we do that through the delete request type, and we will set that up in the next video and test that as well when we want to delete records. So hopefully you got all this working. Thanks for watching, and I'll see you in the next video. Hello, welcome back to our REST API tutorial series on Turbo 360. Thanks for watching. In the previous video, we set up our put handler so that we can update resources on our backend. So that means we have our gets, our posts, and our puts properly set up. So the last thing to implement is our delete, so that we can remove a resource if necessary. So in this video, we're going to do exactly that. We're going to set up a delete route handler that can be called by our API to remove a resource specified by entry ID by resource identifier, just like the puts. So let's go ahead and get started. So here we are at the end of the last video. We have our, like I said earlier, we have our put and our posts and our gets. So let's go ahead and implement our delete down here at the bottom. So create a new router entry. We're going to call it delete, of course. And it's going to take a resource identifier, same as always. I'm sorry, a resource name, and then the resource identifier, so we can specify specifically which resource we want to delete. And then, as usual, we have our request response callback. Like before, we're going to grab the controller from the controllers object. I'm just going to copy and paste that because, like I said before, this is pretty much reviewed by now. And then once we grab the controller, we want to call the delete function. And the delete function is going to take an ID parameter. And that should pretty much be it, because this is enough to find the specific resource entry and then remove it from the database. However, as I'm sure you've noticed by now, this function does not exist within either of our controllers. So let's open these guys up and create it. So here in the player controller, I am implementing a delete function, which only takes an ID. And same as usual, it will return a promise, which takes a resolve and a reject argument, same as always. And we have the player schema here, so we want to do find by ID and remove. That is the mongoose function for removing a record from the database. And then we just pass in the ID, and that's it. And then it returns a promise, same as always. And we handle the error like we usually do, just by rejecting the promise. And here, there is no callback. Well, how can I put it? There's no data in the callback that we need. The removed player, the player has been removed from the database. So all we need to do here is resolve with an empty empty argument. However, what I normally do is include the ID like so, because sometimes the client that's calling this function needs the ID in return to know which entity was removed. It's just a little convenience mechanism I use to keep track of stuff. So here, this should take care of our delete player controller function. So let's head over to our team controller and do the same thing. So don't forget the comma here, and then just implement that and replace player with team, and we should be good to go. So now the API route can now call this function as a promise and we can do what we normally do. So let's implement the error callback first, and here is the success callback. And then we just want to pass in success, of course, and then data is the data, and this is going to be just the ID, basically just returning this parameter right back to us so that we know specifically which entity was removed. So now this should be set to go. Let's go ahead and test this using the same curl mechanism function in the terminal that we did last time. So here is the terminal. Make sure you have your Mongo server running. If you don't, just open a new tab and do Mongo D like so. And then let's run the turbo dev server. And then let's open another tab and use curl to test this out. So we want to set up a curl function, set the header to content type application JSON. We want to set the method to delete. Technically this doesn't have to be uppercase, but it's just a habit that I maintain. Now there's no body here, so we don't need to include any JSON in the request body, so we can just send it as is. So we can just start adding the address now. So localhost 3000, this is the API route, and let's remove a team. And let's get our list of teams. So we have these 4 teams currently in the API, in the database. So let's remove this one right here. Let's just pretend that they were they moved or something like that. So we grab the ID, right? And remember the API endpoint is the resource and then the ID. So we have the resource specified right here, team. Now we need to pass in the ID. And hopefully this will return a confirmation message with only the ID returned to us in the data payload. So here we are, right there. And what that means is it successfully executed. So if I rerun the team API team function endpoint, the Houston Texans should no longer be here. And that was successful. So we now removed one of the teams. And let's try it also for player. So we have these 4 players. So let's remove this one right here because he belongs to the Houston Texans. So let's remove him as well. So we run the same function, except now we change the resource to player. We grab the ID from here, we copy it, and we change the ID to that specific player, like so. And then we run it, and we get the success callback. And now this player, JJ Watt, should no longer show up in this endpoint payload. And that is exactly what happened. So we are good to go. So our delete endpoint has been properly set up. And now this completes the full CRUD application implementation of the API. And this follows the standard API conventions. And so this is a pretty good starting point for creating your own API. A good thing to note here is that since we are using controllers, There's no need to import the actual models directly. That way we can plug in new resources and remove resources pretty easily. It also doesn't tie you down to certain database types. Like there's no mention here of Mongo or really anything. So you really use pretty much use this exact same implementation if you want to use Postgres instead, or MySQL, something like that. And the controllers are where all the internal logic essentially takes place. So here's where you would move the custom logic for each resource in and out. Now these controllers are pretty similar, almost identical, which you probably picked up on, and that's considered not really best practice. But the only reason that is in this case is because the project is so simple. The idea behind the controllers is to implement custom logic as it pertains to the specific resource. So a good example here would be player. Inside the player resource, if we had another attribute like password, in reality what you would want to do is you want to hash the password, and so you can do that in the controller on the post call. So this would theoretically be happening when a user is signing up for your application. And when a user signs up, typically they enter their password saying you sign up with your email, password, username, password. So here you can do all your password hashing here before creating the player in the database, and the controller should handle that custom logic in this case. This is one way I use controllers to my advantage in my projects. So the team controller, of course, wouldn't have that, at least not in this scenario. So the controllers handle custom logic as it pertains to the specific resource that it manages. And so even though right now they're pretty much identical, almost identical, in a normal project that wouldn't be the case. So that's it. Hopefully you got all this working. This completes the full CRUD operation. So in the ensuing videos, we're going to work on deployment, as well as showing examples of making this more extensible, adding and removing new resources. So hopefully this works on your end. Thanks for watching, and I'll see you in the next video. Hello, welcome back to our REST API tutorial series on Turbo 360. In the previous installment, we finalized our CRUD operations by setting up the delete endpoint and tested it by removing a player and a team. So now we're ready to deploy our project, which we're going to do in this video. We're going to connect our project to an actual database, a live database, and then we're going to deploy to the turbo staging environment, which we did in the initial video, but now everything's set up and ready to go. So we're going to redeploy and test our endpoints on a live staging environment. So let's go ahead and get started. You're going to need a few things. You're going to need an account on MLab. So this is free. So head over to mlab.com and sign up for a free account. And we're going to create our Mongo database in here. And then going back to our first video, you're going to need your project on Turbo 360, which we created in the initial video. We're going to redeploy to this staging environment with the database connected. So make sure you have that ready to go. And let's go ahead and get started. So I'm going to log into my MLab account. And create a Mongo database on MLab's infrastructure. So some of this I'm going to go through a little bit quickly, but if you're not familiar with Mongo and how all that works, just head over to turbo360.co and check out the Mongo DB tutorial where we cover all of this from the bottom up. So we're going to create a new database on the Amazon platform. It's going to be Sandbox, and I'm going to pick, well, continue first, and then US East 1, because I'm located in the East Coast. We'll call it REST API Demo. Go ahead and complete that process, and then inside the REST API Demo database, we need to create a database user. So we're going to create an admin user, put in whatever password you want. I'm just going to say Turbo360. Turbo360. And then create. And then what this will do is it will give you a production URL. So now we want to use this. Now keep in mind we have the DB user here and the password here. So the user will be admin and the password will be Turbo360 in my case. So here, going back to my project, we now want to connect on line 8 the environment variables for the MongoDB URI and the prod MongoDB URI. Well, what we just created is the production MongoDB URI. So we want to copy that, and this is coming from the environment variables. So we want to open up the environment variables and create a entry for production MongoDB URI and copy it from the mlab installation. And then go back here and then just paste it in. Now remember to change these. So it should be admin and then Turbo360 in my case, and then obviously whatever the password you have for your project. And then going back to the app.js, we have the MongoDB URI, which is the local URI database. And that we need to create an entry for that, and that's going to be the same one as before. And now this is our local entry, and this is our staging, our live database. So if we head back to app.js, we can now re-implement this URL entry on line 8 and remove our previous one. And this should now properly connect to the database depending on the environment. If you look at the conditional here, this is called a ternary statement. If you look at the ternary statement, you'll see that the dev environment is what determines which database URL is connected. So going back to our env, turbo env is dev, but when we deploy to staging, this automatically changes to production. So you don't need to worry about that. It'll just happen on the production environment. So we want to test it both locally and on staging. So open up another tab in your terminal and run the MongoDB if you don't have it already running. And then run the turbo dev server. And make sure everything still works. So we have our local host and then API team, player, so forth and so on. Now remember, this is the local database. So none of this will be on the staging environment over here because this database has nothing in it. So we now want to deploy it. So if you may have forgotten to do this from the first video, or you may not have done it yet, we can just do it again, connecting our project locally to our environment, our Turbo account project. You copy the app ID, and then you do Turbo app, and then paste in the ID. And this will connect your Turbo project local source code to your environment on the Turbo staging environment. So once you have that, just also do turbo login to make sure that you're logged into your account. Once that's confirmed, just do turbo deploy, and this will deploy your project to the staging environment. And once that is complete, you will be given a staging URL where you can test the endpoints on the live staging environment. Okay, deployment is ready, and then here is the staging URL. So instead of localhost 3000, we can just plug in the staging URL instead, and I'm going to do the general player request. And here we go. And here we have the endpoint payload for all the players. Here's the one for all the teams, and of course there's nothing in the database, so you're not going to get any data back, but we can test these scenarios. Team 123 not found, player 123 not found. And so that's it. It works. So now what we want to do, or we don't, essentially our REST API is set up and ready to go. The question now becomes, how do we use this? Well, the API right now is well designed in a REST fashion for other client-side applications to consume the REST API. So normally what would happen next is there would be some sort of client-side application or project that uses this API to render data. So for example, it might be like a React application or an Angular 2 project or even an iOS project or an Android project. And no matter what kind of client-side application it is, they should all be consuming the same API so that it's very easy to build client-side projects against this API so that you can build a lot of things. You can build a whole family of applications all centered around this API. And since the API is very RESTful, it should be very intuitive for a developer to work around your API to develop a product or client-side application using your data system. And typically that would be a front-end developer on your team or something like that. So hopefully that makes sense, and hopefully you got everything working. This concludes the REST API tutorial. Thank you very much for watching. And if you're interested in other tutorials like this and more advanced tutorials, you can just head over to turbo360.co, where we have a lot of tutorials that are more advanced and get into full projects. So you can take a look over there to find more content. So thanks a lot for watching. Hopefully you enjoyed this tutorial, and I'll see you in the next one.